All right, welcome to class. We just want to discuss internal resistance of a cell, and there are some key points we need to note. Please, let's quickly provide solution to this. First thing is that I want to talk about the arrangement of cell. One, the arrangement of cell. So we have when the cell is in series format. When it's in series format, what do we know in the series arrangement? So we have this value, we have this value, we have this value here protruding to give us this. Next up is that for series arrangement, two things we know for cells, two things we need to note. First is the EMF. So the EMF, which is our E, is what we need to know. For series arrangement, if this is A, if this is B, and if this is C, that means you have E1 here, E2 here, and E3 here. That's what I mean. That's why I'm naming it as A, B, and C. So it's the same thing here. So if you want to calculate the EMF here, we say is the addition of the three EMF. That is all. So add them up. Next up, how do I calculate the internal resistance for this? So this is my R1, R2, and R3. Is that we are going to add them up as well. Add them up as well. So this is how you do this one here. So for cell that is number 2 now, cell arranged in parallel. How do we do that? Cell arranged in parallel. We know that here we have this and we have this here. So this going up here to give me this. So I have this. This is how the arrangement is. So how do we find our EMF here? EMF, I told you that is our E here. I just told you now that is given as E. So how do we find this one here? Is that if here is E, that is E, E, and E. So if here is 3, 2, and 1, it means that whatever the value is here, just pick one of the values. Even though they are arranged in 3 cells or in 2 cells or in 4 cells, the EMF here is given as this. So which we say E1 is equal to E2 is equals to E3. That's the meaning of this. Meaning that if here is 2, if the EMF here is 2, 2, 2 across the cells, just pick one. But for this one, the EMF should be added. That's what we mean. The EMF value should be added. Now, how do I calculate my internal resistance here? For this one, for 3, we said is 1 R here, 2 here, 3 here. That's the arrangement to this. But if it is 2 cells given to you, for 2 cells, we arrange it the way it is given. Please, it's always small r. Please, it's always small r. This is how it is noted. So this is the 2 things we need to know going forward. Next up now, what do we need to know again? Number 3, we need to know that Ohm's law is playing a big role here. Very important. Ohm's law is playing a big role here. So where my V means my potential difference. Potential difference. That's my V. My I here means my current. My current in ampere. And this is in volt, please. In volt. My R here means my resistor or resistance. It's the same thing, which is measured in ohms. Is measured in ohms. So this is what I need to know. Next up, for internal resistance, we also have another formula going forward. We said is E all over R plus this. The relationship between EMF, current, internal resistance, and resistor. This is it. This is another thing we need to know. This one here. So what is the next thing we need to know? Number 5 is that we need to know that EMF is also connected to a loss voltage. This one. So where our IR is our lost voltage. And then our E already, you know, is our EMF, electromotive force. You should know that. Electromotive force, that's my EMF. While V is my potential difference. So these are all what we need to learn as we go forward. Now, secondly, is to start solving questions. Let's start solving questions. So, guys, you are most welcome to this class. I'm telling you, if you're a jambite, you are right. You are planning to write waec, GC, Neco, and then you are in 100 level. this class is for you, this channel is for you. Please tell it to everybody around your place. Share this channel, tell them to join, tell them to follow, because they are going to learn a lot of past questions here going further. So let's go. Number one, we are told that a battery of EMF 24 volts and internal resistance 4 ohms is connected to a resistor of 32 ohms here. 32, please, 32 ohms here. They said, what is the terminal potential difference of the battery? So this is a WAEC question 1998. WAEC question 1998. It's a WAEC question. So what do we do, or what do we know going further? First task is to list out the given parameters. What are we given? Watch it here. We are given our EMF, which is E, to be 24 volts. That's the first thing we are given. It says as an internal resistance. Please, the word internal means inside, and internal resistance is small r. Oh, I did not state it here. Internal resistance, please, it means small r. Internal resistance, please, it means small r. While external resistance or resistor means big R. Please note that, please. Internal resistance is IR. Internal resistance is inside. That means small r. Small r is internal resistance. Big R is external resistance or external resistor. Please note that. So we are giving that this is internal resistance. So small r is given to be 4 ohms here. It's connected to a resistor. So since we have small r here, that means big R is also given to be what? 32 ohms here. We have to calculate the potential difference, V. We want to find V. That's what we want to calculate, V. How do we go about solving this question? What do we know to do solving this question? What do we know to do solving this question? Now, simple. Since we have E, we have small r, we have big R, we are looking for V. That should suggest to you that we must first of all look for current. So remember, I gave you this formula, which is this, to give us this plus this. So let's find this and then use Ohm's law in relationship to get our V. So what do we do here now? We know that current here. What is my E going further? My E is 24. What is my big R? My big R is 32 plus small r, which is this. So this will give me 24 over 36 here. So you can either leave it like this or you go further. So me, I will leave it like this and go further. So we are told that, recall that our Ohm's law is giving us this for us to get V. V is a potential difference, guys. Potential difference. So we say V, because what's my current here? It's 24 over 36 times. What is my big R that is given to us here? It's 32 here. That is what is given to us. So what do I know going further? I will multiply. So 24 times 32 here. That will give me 768 here, divided by 36. So if I divide that by 36, I'm having this here to be 21.33 volts. So this becomes my potential difference going forward. That becomes my potential difference going further. So it's as simple as this. Question number two. Question number two. Question number two. We are told. Question number two. We are told here that. Where are you? Okay. We are told that. Number two question, please. A cell of EMF. A cell of EMF 1.5 volt and an internal resistance of 2.5 ohms is connected in series with an ammeter of resistance 0.5 ohms here, and a resistor of resistance 7.0 ohms. We are asked to calculate the current in the circuit. The current in the circuit. So this is a WAEC question 1990. So that is why I said you are most welcome to this channel. You are going to learn a lot in physics, in further maths, in chemistry, and in mathematics going further. So how do we provide solution here? The first thing we need to know here, question one is tax one, sorry, is that we have to list what and what is given to us, please. So EMF has been given. So E has been given to be 1.5 volts. They said it's connected to an internal. So small r has been given to be 2.5 ohms. Here, they said it's connected in series with an ammeter of resistance. We don't need ammeter in the formula. Ammeter is not needed in the formula. So we are going to ignore this one. This is what we need. And a resistor of this, that means big R, is given to be 7.0 ohms here. So calculate its current. So I is what we want to calculate. It's very, very simple going forward. So we want to use that formula. Use that formula here now, where we say I is equals to E over this plus this. Reason is because we know our E. What is our E there? Electromotive force is this. What is our big R? Our resistor there is 0.2 plus what is our small r there is this point this here. So I have 1.5 here over 9.5. So if you do the math going further, you will realize that our final answer here becomes 0.15. Let's put 0.16 then ampere here. So this is it. This is how this is worked. This is how this is solved and sorted out. Next up, going further. Next question here is question number 3. Next question is question number 3 here. We are told that a battery of EMF 10 volt and internal resistance 2 ohms is connected to a resistance of 6 ohms. We are asked to calculate its PD across the terminal. Calculate the PD across the terminal. So this is what we have here now. So first task is to identify what and what is given to me and you. First task is to identify it. Now, what and what are we given here? EMF has been given to be what? 10 volts. An internal resistance, which is small r, is given to be 2 ohms. Is connected to a resistance. That means big R is given to be 6 ohms. They said we should find the PD. PD is our V. That's the meaning. Potential difference. Potential difference is known as your V. So what do we know going forward here? We are going to first of all calculate current before we now calculate V. Remember the formulas I gave to you. In this case, like this, anytime you have to calculate potential difference, PD, which is your V, know that they're asking you to use this formula first, and then use Ohm's law formula. That's how it is. Whenever you have to calculate PD, solve for current first, also whatever is given here, and then you now use Ohm's law. So let's go ahead. First, we say recall that my current becomes this one, this plus this. So what is my E here? My E, which is my EMF, is 10. What is my R here? Is 6. plus what is my small r here is 2. So going forward, I have 10 over 8 here. So I can cut this one down, have 5 over 4 ampere. Remember, I've gotten my current here going further. Now, what's the next thing I'm going to do now? I am now going to employ 4 question. My number 4 question. We are told that number 4, calculate the terminal potential difference across 20 ohms resistor connected to a battery of EMF 15 volts and an internal resistance 5 ohms. So what do we know? First off, what do we know here is to list out the given parameters. So the given parameters here, first we're asked to calculate the potential difference. So we want to find V. Potential difference means your V is given to a resistor. It's connected to this, and then resistor has been given, big R has been given. Next up, it's connected to an EMF of 15 volts, and then an internal resistance of what? Of 5 ohms. It's simple. So what do? We say recall that since we are given this to calculate, I told you that anytime you want to calculate this, you use the current formula, the formula that has the relationship between electromotive force, resistor, and internal resistance, and then you now use Ohm's law and solve it. So we now know that this is it. This is the formula that has the relationship with all of those things I've mentioned. So let's get current first. So what is my E here? My E is 15 here, all over. What is my big R? My big R is 20 plus what's my small r is this. So that will give us 15 over what? 25. So 5 can go here, 3, 5 can go here, 5. So I have my current to be this. This is my current now. So how do I use my next value? So we'll also say recall using Ohm's law. Ohm's formula, please. Ohm's formula, we know that this will give us this. Why are we using this? Because we want to find potential difference. So V becomes, what is my current now? 3 over 5 times, what is my resistance there? 20. So if you do that, here is 4. So V therefore will give us 12 volts. So that is how you do this. Next question, number 5. Number 5 question here. We are told that two identical cells, each of EMF 2 volts, and internal resistance 1.0 ohms are connected in parallel. They said the combination is connected. The combination is connected to an external load, 1.5 ohms. We're asked to find. Okay, this question, please. This question we just dealt with now is a waec question, please. A waec question, which is 997. Waec question 997. So the next one here is waec. We asked to find the what? Find the current. So this is a waec question. Waec question 2003. So this is it. Solution, please. It's very important you share this video. It's very important you tell this to your friends, you tell this to your colleague. In fact, you are lucky to find this channel. If you are a jambite, you are an 100 level student, you are planning to write this GC, Neco, waec coming forth, please Learn this, please share this channel, tell it to your friends and your colleague everywhere, tell them. So let's do this one now. They say two identical cells. So EMF has been given to be this. They said it has an internal resistance of this. So please, my emphasis is this one. Because they said it's parallel, I told you how parallel cells work. Your electromotive force is still remain constant. But this will be changed. Your internal resistance will be changed. Since they said it's 2, we are going to use this formula to change it. So where we have R1, R2, R1 plus R2 here. So this will become 1 plus 1. All this is 1. This one means 1. So over, this is 1 times 1, sorry, and then 1 plus 1. So here will give us 1 over 2. So this becomes my new internal resistance here. They said it's combined to this. So R has been given to be 1.5 ohms. Want to find current? It's simple, guys, to find current. That's all. So what do I do now here? We say recall that your current becomes what? E all over R plus this. Very simple. What is my E going further? Is 2. What is my R here? Is 1.5. What is this one here? Is half. This is what we use. No longer this is this one now. Half. So I have this. Here, I'll find my LCM here. Bring this 2 down first. All over. What is my LCM? This 2. This is it here. What's my LCM here? My LCM is 2 in the denominator. So 1 in 2 will give us 2 times this one is 3. Plus this one will give us 2 into 1 times this one will give us 1 here. So from here, what do we know going further from here? We know that from that point, I will have 2 over this one here. Now 3 and then 1. That's 3 plus 1 will give us 4 over 2. Applying indices, guys. So these 2 are together. This becomes divided by 4 over 2. So here, 2 over 1. Change your times. As you are changing your times, the right hand side changes. Here becomes 2 over 4. So 2 times 2 is 4 over 4. Here will give us 1 ampere. So this is how we solve this going further. So next question, number 6. So I'm having my number 6 question here. We are told that 4 identical cell each, EMF and 4 identical, nope. This is a different question. Okay, 3, please. 3 electric cell each of EMF 1.5 V and internal resistance 1.0 ohms are connected in parallel across an external resistance of 2 over 3 ohms. Full stop. We're asked to find the value of the current. Find the value of the current. So this is a jamb question. 1997. It's a jamb question. So this is it. It's a jamb question. 1997. So what do we know going further here? First thing to do here is that we want to quickly identify what is given to us. So let's quickly do that. So solution here. So what do we know that is given to us? We are told that 3 electrical of this value, EMF, is given here to be 1.5 volts here, and an internal resistance of this, so small r, is given to be 1.0 ohms. They said it's connected in parallel. Don't forget that. Because connected in parallel, you cannot use this one. Whenever they say it's connected in series, you can use that. You are correct. In series, you can just add this plus this in 3 places. But in parallel, you cannot use this one like this. What do you do now? You are going to use this formula because it's 3. You are going to use R1, R2, R3. So that will give us 1 over what? 1 plus 1 plus 1 here. Am I correct here? Remember, we have this. It's like this. This is the formula. So everything here will give me 1. Check my LCM here is 1 plus 1 plus 1. Very important. So this is 1, please. Very important value here. So here we now have 3 over 1 here. So over this R, if you cross multiply like this, we now have that. Here, I have 3R will give us 1. We are looking for R, the new value for R. Divide both sides. So R now becomes 1 over 3. This is the new value for R. So don't forget that we are giving big R here. So big R is given to be 2 over 3. Don't forget that. So what do we find as our current? So we say current therefore becomes this value to give us this and this. So what is my E here? The value given to us is 1.5 over this one is our 2 over 3 here, plus the new value now is now 1 over 3. Very important here. So 1 over 3 here. Find my LCM here. In the denominator, I'm having this. So I have 2 plus 1 here. 1.5 here. 1.5 will give us what? 3 over 3 here. These are together. This one, they are together now. So let me separate this. So I'll say 1.5 over 1 times 3 over 3. So do the math now. Do the math now. So 1.5 times 3 now. I'm having this. I'm having 4.5 here. Divided by 3. I'm having 1.5 ampere as my value. So this is my question 6. Very important. This becomes my question 6 as my given value there. Very, very, very important as my given value there. So next up now, what do we know is that we want to do number 7. Number 7 question. Here, we are told that three cells of EMF 1.5 V, very important, and an internal resistance of 1.0 ohms are connected in parallel across a load of resistance 2.67 ohms. We have to find the current, please. Find the current. Find the current. So this becomes what? A jamb question. 1990. It's a jamb question. 1990. So let's quickly profile solution to this. So what do we know going further now? We know that first our EMF has been given to be 1.5 volts as our EMF. Internal resistance now is given to be this value. And I told you that we're not using this value. So this is it. It's still the same thing here. It's still the same thing. So our new value we are going to be using now is 1 over 3 ohms. Please, it's very important. Note this thing. Our final, this here is 1 over 3. Why? Is because it's connected in parallel. So what's the next thing we are going to do going further? Observe that we are giving big R. Big R is 2.67 ohms. So how do we calculate our current? To calculate our current here now, we know that this will give us E over this plus this. So what is my E here? My E going further is 1.5. I have this. What's my big R there? Is 2.67. Then plus, what is my new value for internal resistance now is this. So what do I know now? I know that 1.5 here. Find my LCM of the denominator is 3 here. So 1 in 3 is 3. 3 times this value. That's 2.6 times 3. I'm having 7.8 plus this in this is 1. 1 times this will give us 1. So all this one will give us 1.5 all over divided by 3. Indices, these are together, don't forget. So I will put divided by 8.8 divided by 3. So 1.5 over 1 times 3 over 8.8. Very important value there. So what do I know now going further? What do I know going further here? If you multiply 1.5 times 3, I know I have 4.5. So 4.5 divided by 8.8. Divided by 8.8. That will give us, my current here will give us 0.5 ampere. So this is how this is solved. This is how they are solved. This is how they are solved going further. Please, if this is your first time of coming across this channel, please tell this to your friends and brothers. If you're a Jambite 100 level student, waec, Neco, forthcoming GC, this is the place you must be. We are solving a lot of past questions here. See you in the next class. Bye bye.